In the previous video, we looked at comparable interface and how it can be used to sort a list and array of our own objects using Collections.sort and Arrays.sort methods. For this, we need to make our custom class implement comparable interface and implement its compare_to method. This is our custom class student which implements comparable and its compare_to method which will sort the objects in increasing order of the roll numbers. In today's video, we will understand how to sort a list using another built-in interface, Comparator, along with the differences between comparable and comparator, which also happens to be a very commonly asked interview question. If you have not watched the earlier video, I would strongly recommend you to watch it to understand this video better. Let's start. Create a new class. Name it roll number sorter. This class will contain the sorting order using comparator. For this, make it implement comparator. When you implement comparator, you need to implement its compare method. Compare method accepts two arguments which are the objects on which sorting will be performed. As opposed to comparable, the compare method of comparator accepts two arguments. This is because comparable is implemented directly by the class whose objects we are sorting, and therefore one object is an implicit object which we call as this. Comparator is also a generic interface, and to make it specific to student object, add the type in angle brackets. Now we can change the type of arguments to student and will not be required to perform casting. Compare method also returns an integer value similar to compare to, and it can be three possible values, -1, 0 or 1. Compare will return the difference between the roll numbers of the argument objects. Now, how do we use comparator to sort the list of student objects? If you look inside collections class, there is an overloaded sort method that accepts a comparator argument along with the list. It will sort the list according to the criteria provided in compare method of this supplied comparator object. So, to sort this list, we will provide an object of the class that implements comparator that we just created. We can remove comparable implementation from our student class now. Run the program. It is working. Similarly, arrays class also has an overloaded sort method that accepts a comparator argument. So, same object can be used to sort an array of objects as well. Instead of creating a new class for implementing comparator, we can provide its implementation here only as an anonymous class. Create a comparator of type student. Implement its compare method here only. Provide this object in place of roll number sorter class. Run the program. Works. So, now we don't need a separate class that implements comparator. Starting Java 8, we can represent a functional interface as a lambda expression. Now, what is a functional interface? An interface that has only one abstract method. If we look at the definition of comparator, then it is also a functional interface since it has only one abstract method. Also, if an interface has this annotation, then it is a functional interface. Benefit of lambda expression is that you are not required to create a new class. You can provide the definition of abstract method of functional interface here only. To define a lambda expression, provide the arguments expected by the abstract method, which are 2 in this case. We are not required to provide their type. It is automatically inferred. This is followed by an arrow and the required implementation, which will be the difference of roll numbers. We can assign this to a comparator of type student. Pass this object directly to sort. We don't need this anymore. Run this. Same result. Now when we have understood how to use comparator, let's understand the difference between comparable and comparator. First difference is obvious. Comparable has compare to method while comparator has a compare method. Compare to accepts a single argument, and this is because one object is the object on which compare to is called, while compare accepts two objects. If we are using comparable, then we have to make the class whose objects we have to sort implement it, while for using comparator, we can create a new class that implements it, or we can also provide the implementation of compare using anonymous class or lambda expression. This also means that for using comparable, we need access to the class whose objects we need to sort, while comparator can be used with any class, even those whose source code we do not have. With comparable, we can provide only one sort criteria. That is, we can either sort objects on one field or other. While with comparator, we can create any number of sort sequences by defining a separate comparator for each sequence. Another difference is that comparable resides in java.lang package, while comparator in java.util. These are the important differences, and based on these, we can easily see that comparator provides a more flexible approach to sort custom objects. That is all for this video, and I will see you in the next one.